This is Scott from KIG. It's May 24th, 2017, and today we're going to do a runoff of this refurbished ThermalCare 20-ton air-cooled chiller. I'm going to start by just opening up the cabinet here, showing you which serial number this is. This is an HQ2A2004, serial number 58940010008. It's a 460 volt 20-ton air-cooled chiller. We're going to start by, actually before we put the power to the unit, we'll talk about a couple things. For this test, for the lower side cut, we don't have to have the lower side covers on. We do have all these brand new doors with new hardware that pop right on these hinges here. So this we would consider a substantial refurbishment. We took the tank out of the unit because this is a tankless application for the customer. Put in a brand new 5 horsepower chiller, 5 horsepower water pump, and brand new piping here. We have a brand new strainer, Y strainer, which here, if you take this out, has a what they call a 20/20 mesh filter, mesh screen that should be checked regularly. We flushed and cleaned the heat exchanger and put new insulation on it. We have this new fitting here, which goes to the pump pressure gauge. We have this pressure fitting up here. And here we have our flow switch, which senses our flow. And this here is our temperature sensor, which goes back to the controls. This has 2 scroll compressors, 10 horsepower Danfoss. And what we've done is we've painted the entire base of the unit, removed the tank, and we have it set up with our test tank here, which is right about at a little over 70 Fahrenheit right now. We don't have to use the pumps for this particular test today. And we have a brand new gauge, and we also bought these Velcroed on coil covers, brand new from Permatrol, I think it is, Permatron, and it also brand new touch display here, or the overlay, I should say. So we're going to start by just turning on the main incoming power. And we'll talk about a few things. First that you see is that little sign that says off delay, and then we can go to start. Actually, we're probably still in the delay right now. What we have inside here, we did paint the inside of the control cabinet a little bit more, and we've actually went ahead to added a 2 timers here, one for compressor on delay, that's hooked up to one compressor, one for compressor off. The compressor off is tied in with the hot gas bypass circuit. We added those ourselves in addition to this relay, and those two things combined give you some level of control. Oh, I'm sorry, I was pressing start, not power. That gives you some level of control over the staging of the compressors. Because in standard form, the unit would turn both compressors on at once. We just want to give the customer a little bit more flexibility than that. So with straight water, I don't want to have a set point for this unit if you're running straight water below 53. And right now, the unit does start. So the first thing that happened is one of the compressors came on, and both fans. And we'll label the contactors here, but this contactor's pulled in. This one's not going to pull in to cool down until our compressor on delay kicks in. So the logic is there is if while you're running you meet set point within a certain period of time, say 2, 3, or 4 minutes running off one compressor, that's all you want to do. if after an adjustable amount of time you're not meeting set point, then the second compressor will kick on. Conversely, when we get closer to the set point range, in this case 53, the hot gas bypass, which is indicated by partial load, that will come on, and we actually have an off delay built into the other compressor. Between those two things, we can explain it in more detail over the phone to the customer. You have some adjustability to kind of fine-tune kind of a very simple staging of this unit, which again is above and beyond what the factory did as standard. In this case here, because we have the water kind of high, you'll see it'll say over set point and high water temperature, but our indicator lights, you know, compressor on and pump on. Now we have probably in our test tank probably 130, 140 gallons of fluid, so it'll take a little while to start cooling that down substantially. You can see we're starting to cool down a little bit already. What we're going to do here is on my on delay. Oh, just kicked in. I think it was like a minute or two. So now both compressors are on. That's your compressor number 2 contactor. So, we have a freeze stat here. That freeze stat is tied into the fluid line right next to the heat exchanger, and that's set at 35 Fahrenheit. And that's just for protection. If somebody sets this dangerously low, that's going to turn the chiller off, because you don't want to get below that temperature. So now we have 2 compressors going. It's actually chilling pretty well. What we have up above, or behind these panels here, is we have two squirrel cage blowers up above here, and those are high flow. We got new belts for those, and we adjusted the motors and the belts. Those are high flow condenser fans up above, and that's suitable for ducting out of your building. It is an indoor chiller, of course, but you can put ductwork right over the top of that. That's a extra charge, extra feature the original customer purchased. Here we have your low pressure and high pressure refrigerant switches. You don't have to touch those. Don't play with those. This one here, if anything were to happen, that's the low pressure, that's the high pressure. This one does have a resettable switch. An example of a low pressure would be if you're running the water temperature too cold, or if you're not getting enough flow over your exchanger. In this case here, we simply have your inlet line, which is going out to our test tank, and your outlet line going to our test tank. And we trying to see if we're throttling it. Yeah, we're throttling it a little bit back with the shut off in the tank, because if your pump wants to see a little bit of back pressure. I'm sorry, we got to throttle back a little bit there. If this were a chiller that had its own internal tank, we'd have a bypass for the flow. That's not needed when you have a tankless set up like this.